I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we'll see one important algorithm used in unsupervised learning algorithm that is known as K-mean clustering. Very, very important algorithm used in the unsupervised learning. So what is K-mean clustering? K-means clustering is a type of unsupervised machine learning algorithms that is used to group unlabeled data into meaningful clusters. The term unsupervised means the algorithm works on data without predefined categories or labels. The algorithm divides a dataset into k distinct non-overlapping clusters with each data point belonging to clusters with the nearest mean centroid. The ultimate aim of K-mean is to ensure that the data within each cluster is as similar as possible or low intra-cluster variance while keeping the clusters as distinct as possible from one another. What are the key concepts used in the k-mean clustering? Data points. The k-mean clustering algorithm is based on few fundamental concepts. Each data point represents an item which is specific characteristics, that is features. A centroid is the average positions of the points in a cluster and serves as a representative center. A cluster is a collection of data points grouped together based on because they share similar characteristics. The distance between the data point and the centroid, usually measured using Euclidean distance, determines the cluster to which the point is assigned. This method ensures that each point belongs to the cluster whose centroid is nearest to it. And then the algorithmic steps involved in the k-mean clustering is the k-mean clustering algorithm follows an iterative process to arrive at a stable clustering. First, the number of clusters k is chosen. Then k initial centroids are selected randomly from the data set. Each data point is then assigned to the nearest centroid and forming k clusters. After all assignments are made, the centroids are recalculated as the mean of points in each cluster. This process of assignment and centroid updating continues until there are no changes in the assignment, indicating that the algorithm has converged to a stable state. So we have to repeat 3 to 4 steps. Let us see one example. Let us take on now 2D data to illustrate the process of k-mean clustering. We'll consider a simple 2D data considering of 5 points. X is equal to 2 comma 10, x2 to x1 is equal to 2 comma 10, x2 is equal to 2 comma 5, x3 is equal to 8 comma 4, x4 is equal to 5 comma 8, and x5 7 comma 5. So here this example is selected to demonstrate the algorithm's capability in grouping points on their special proximity, and in this case we will consider k is equal to 2 clusters, meaning the algorithms will divide the data set into two groups. These initial groups points provide a clear structure for visualizing how the algorithm works step by step. First iteration, and in this given the data set, so we are going to consider thus how we are going to consider means we are going to consider the 2D data and two clusters we are going to take into account. And here these are all the data. X1 is equal to 2 10, x2 x3 and x4 x5. Here to form two clusters we are fixing k is equal to 2. What is the second step? Initialize the centroid. Initialize the centroids. Let's choose, we have to choose initial centroids from the data sets. Randomly we'll select C1 is equal to 2 comma 10 and C2 is equal to 8 comma 4. When we then compute the distance of each data point to both Euclidean centroids using the Euclidean distance formula. Each data point is assigned to the cluster with the closest centroid. As a result, the dataset is split into two groups based on which centroid each point is closer to 2. This step is critical as it informs the foundation for determining how the centroids will shift in next iteration. So this is the formula for the Euclidean distance x2 minus x1 the whole square plus y1 minus y2 the whole square. And we have to substitute. I have told you how many clusters we have split into C1 and C2. And here, these are all the values. All you know that these are all the data points x1 to xy. So C1 we have considered randomly. We have chosen C1 is equal to 2 comma 0 10 and C2 is equal to 8 comma 4. So we are going to consider this and then we have to find out the assigned cluster. So if you are substituting the that is the values in the Euclidean distance here in this case x1 that is x2 2 minus root of 2 minus 2 the whole square plus 10 minus 10 the whole square is equal to 0. Now, if you are considering this, we can write it as root of this 8. First 8, 8 minus 2. 8 minus 2. Here the 2, the whole square plus 4 minus 10, the whole square is equal to root 36. So we'll be finding out the values, no, and then we are approximately getting 8.5 in this case. So here comparing the C1 value is 0 and here 8.5, the minimum nearest minimum value we have to take C1. Next similarly 2 comma 5 and 2 comma 1, 2 minus 2 and this 5 minus this 5 minus because y2 minus y1, 5 minus 10 is equal to 25 50. And in this, if you are substituting, we are getting 6.1. So 6.1, which one we have to consider? Because this only will be having less value, 5. So C1 we have to take. Similarly, root of 8, comma, that is 8 minus 2, 2 minus 8, the square, 10 minus 4, the whole square, root 36 plus 36, 8.5, here 0. So we have to consider C2. Next, what we have to consider? Next, 2 minus 5, 10 minus 8, the whole square. So 3.6 here, 5. Which one we have to take? Less value. C1 we have to consider. And for this case, 7.1, 1.1. So we have to consider C2. Hope everyone understood this problem. One more time you can see. Next, the clusters what we have chosen is cluster C1. In this problem, the cluster C1 is equivalent to what? So x2, x1, x2 and x4. The remaining things are cluster to x3 and x5. So if you are finding out the formulas for mean of x1 2 comma n 1 10 2 comma 5 5 comma 8. So if you are finding out this value, we are going to get 3 comma 0 and 7.67. That is 2 to 5. Add divided by 3. How many values are there? 3. Here 10 plus 5 plus 8. See, divided by 3. So 3 comma 0 7. So this only we have to consider. Now C2 mean of x3, x 8 comma 4, x5 is 7 comma 5. So in this case we are finding out 7.5 into comma 4.5. So the new centroids we have to write. So from this we found out for a given value we found out 3.0 and the C2 we found out this value 7.5, 4.5. So for the new clusters, instead of taking raw data, we have to again find out the cluster value. So in this two, if we are finding out root of this value, 2.5 is greater, we have less than that C2. 2.83 is lesser than that 5, that is comparing to this 5.5. Similarly, here 0.7 matters, 0.7. And here there is 2.06 and here 4.7 and 7 is there. So we have to consider only 7. Hope everyone understood this problem clearly. Interesting problem. So here the cluster 1, x1, comma x2, x3, cluster 2 we are considering x3, x4 from this tabulation. So here, see here, x3, this is x3 and here it is x5. Hope everyone understood. And since the clusters did not change, the algorithm has converged. So C1 is equal to 3 comma 0 7.67 x1 x2 x4, and here x3 x4 7.5 comma 4.5 we found out. Hope you understood. So convergence means what? How it will be convergence? So with the updated centroid, the algorithm once again calculate the distance from each other to new control centroids and reassign the points if necessary. This cycle of assigning points and recalculating centroids continues will until no point changes its clear cluster between two iterations. At this point, the algorithm has converged and the final clusters are considered optimal. The number of iterations until convergence can easily, that is very depending on the initial central selections and the structure of the data sets. And the final clusters, once the convergence is achieved, the clusters are finalized and can be interpreted for further use. For example, data set, we may end up with cluster 1 containing points x1, x2, so in this case, x1, x2, and x4. And data cluster 1 is contained. Cluster 2 containing x3 and x4. The final centers now present in geometric centers of these groupings. These clusters reflect meaningful patterns in the data formed without any prior labels based on the purely distance-based similarity. And the applications, if you are looking into, and it is used in the customer. K-means is widely used in the across multiple industries due to simply and speed. In marketing, it helps with the customer segmentation by grouping user-based or buying behavior. In finance, it is used for fraud detection by identifying anomalies. It also plays a role in image compression by grouping similar colors or reducing pixel variations. In natural language processing, it helps in document clustering where the similar text documents are grouped. The ability to find hidden structure in unlabeled data make it an essential tool in data mining. Next, coming into the conclusion, K-mean clustering is a powerful yet simple algorithm that offers practical value of grouping similar data points. It works best when the data naturally norms spherical clusters and when K is carefully chosen based on domain knowledge or validation methods like the elbow method. While sensitive to the initial placement of centroids and outliers, K-mean remains one of the most widely used clustering technique to its efficiency, scalability, and effectiveness in real-world applications. Hope everyone enjoyed about this topic. The remaining things we'll discuss in the next lecture. Thank you.